Well, how do you do? This is the third video for the Algebra 2 Common Core Regents exam, and it will cover problems, I don't know, maybe 17 through 24. All right, so let's get right into it. Okay, 17. Here's what's going to happen. Straight algebra. What is the solution, if any, of the equation 2 over x plus 3 minus 3 over 4 minus x equals 2x minus 2 all over x squared minus x minus 12? If you're looking at this saying, Visca, I would not know how to do this. Well, good news for you is you are only solving for one variable. So I can try -1. I need to put a -1 in for the x here. Every single x, I put a -1. If they're equal, then that's your answer. If they're not, you try the next one. You try 5, -5. Put it in for all your x's. Okay, if they're equal, that's the answer. Okay, if none of them work, obviously all real numbers would not work. So your answer would be no real solution. That's if you didn't know how to do this algebraically. But I'm going to show you how to do this algebraically, just as if this was a short answer problem. Okay? Anytime I have fractions that I want to combine or solve for, I really need to get the same denominator. I need common denominators. So the easiest way to do that is to factor everything. All right? So the first thing you realize is this fraction on the right, that's like x plus 3 times x minus 4, okay? All right, so that's the right fraction. I notice, excuse me, the fraction on the left already has an x plus 3. So does this. Wouldn't it be nice if everything had an x plus 3 and an x minus 4? The issue is this middle fraction. I see 4 minus x, not x minus 4. But guess what? If I change these around the minus sign, that's the same thing as factoring out a -1. Okay? And furthermore, what I'm going to do is I'm going to take my 3 and divide it by this -1. What do I mean? I can hold it. I'm going to take -3 and divide it by -1. That's going to give me a +3 when I rewrite this. All right? But first, let's make sure. Oh, no, let's do that now, okay? So this is going to be a -3 divided by -1 turns to a +3. Okay, this goes bye-bye. Okay, we flipped that sign. Now look what I got. Oh, beautiful. It is beautiful. So the fraction on the left has an x plus 3. It needs an x minus 4. So I'm going to multiply this times x minus 4. What I do to the bottom, I also have to do to the top. The fraction in the middle, well, that has an x minus 4. It needs an x plus 3. So I'm going to multiply that by x plus 3. What I do to the bottom, I also have to do to the top. All right? Now, the fraction on the right already has x plus 3 times x minus 4. So let's rewrite this whole debacle, keeping in mind, okay, the numerators I need to multiply. Okay, so 2 times x and 2 times -4. That would give me 2x minus 8 all over x plus 3 times x minus 4. That's the first fraction. Plus now, because remember we have a plus here. I got to distribute my 3. I get 3x plus 9 all over x plus 3 times x minus 4 equals. The fraction on the right doesn't change at all. I still have 2x minus 2 all over x plus 3 times x minus 4. The beautiful thing we can do now that all of our fractions have the same denominators, cross them out. So I'm just going to rewrite what I have here. I have 2x plus 8 plus 3x plus 9 equals 2x minus 2. Look at what I just wrote in red below here. That is so much easier. Now we're just solving for one variable with opposite math. Let's combine any like terms first. Okay, I have 2x and 3x, that's 5x. 8 and 9, it's plus 17, equals 2x minus 2. All right, good, good, good. Let's just make sure we got everything going on. Okay, it's x minus 1. Good, good, good. Oh, look at me. Man, I want to make this bad. See how this is minus 8? I should probably write minus 8 here, which means minus 8 and plus 9 is plus 1. Look at that. Maybe you caught that earlier. If you didn't, it's always nice to go back and check your work. All right, here we go. So now what do? All right, well, let's bring this 2x over by subtracting 2x. Bang, I've got 3x, and let's bring this 1 over by subtracting 1. Equals -3. Wow. If I divide both sides by 3, x should equal -1. All right, so I go back here, look at my answers. -1 is my answer. Okay, that's choice 1. Now, if I didn't know how to do that, because that's not, it's not impossible. It's not difficult. It's a lot of writing. Okay, you've got to keep track of a lot of different things. But if you didn't know how to do that, you could still just plug this in for all your x's. If you plug in for these x's, this side should be the same thing if I plug -1 in for those x's. They should be the exact same quantity. All right, and that's how you could tell. Number 18, data and stats. Okay, for every kind of heavy problem you have, like the previous problem, if you had to do it algebraically, we have a problem that as long as you know something about data and stats, especially this, this jumps right out at me right here. That's the moneymaker. 95% is the moneymaker, and we'll get in that in a second. But as long as you know what you're doing, this should take you all of 2 seconds. Let's read the problem. In 2013, approximately 1.6 million students took the critical reading portion of the SAT exam. The mean score, the modal score, and the standard deviation were calculated to be 496, 430, and 115 respectively. Which interval reflects the 95% of the critical reading scores? That 95% is a moneymaker. That is my mean, which is this symbol, plus or minus 2 standard deviations, which is that little symbol right there. All right, here's what you need to understand first. You see how they list the mean score, then they list the modal, then they list the standard deviation? That is the same order the numbers are in. So my mean is 496, my mode is 430, and my standard deviation is 115. Okay, so my mean, which is 496, plus or minus 2 standard deviations, which is 115. Now, first of all, 430s. Okay, it is not this one. It is 2 times 115. That's the same thing as 230. So I could technically write that as 496 plus or minus 230, because 2 times 115 is 230. Bam. If I didn't have to explain that and I knew, that 95%, that is such an easy question. That's a thank you. Thank you, Mr. Regents, for putting it on there. I don't know, maybe it's Mrs. Regents. How sexist of me to assume that it's a male. All right, this is one of those, random miscellaneous questions, and it has to do more with, knowing properties of the graphs they have in front of you or the functions they have in front of you. Number 19 states, which statement regarding the graphs of the functions below is untrue? Okay, italicized does not mean invisible. You are looking for the one that's false. 3 of these will be true. Do not circle the first one that's true and say, I got this, mister, I did so good on the test. Make sure you understand what you are looking for. Okay, one of these 4 things is false. Let's take a look at choice 1. Okay, f of x and j of x have a maximum y value of 3. Okay, f of x is a sine function, and here's my amplitude. It goes up to 3 and down to 3. So that's true. This does have a maximum value of 3. and j of x. Okay, this is a negated absolute value, which means it's going to be an upside down v. And guess what? It's going to move right 2 and up 3. So here's 2, here's 3. Boom. That is absolutely has a maximum of 3. If you did not know that, guess what? You have a calculator. Graph these all if you need to look at them, all right? Let's look at number 2. Okay, let's look at number 2. All right, f of x, h of x, and j of x have one y-intercept. All right, let's look at f of x. That's the sine function. If I'm going to graph that, I know sine looks like this, okay? It goes something like this, and comes through here. Yeah, it does. It touches the y-axis once, okay? That does have one y-intercept. H of x, does it have one y-intercept? Oh boy, it does not look like it does at all. Let me clear some space here. If I'm graphing the log of base 2 of x, it's going to look something like this. It's closer and closer to the y-axis, and never really touches it. That has 0 y-intercept, so that is false. This is the one thing that is untrue. All right? Again, if these are things that you have difficulty knowing, you have a calculator. You graph each one of these, okay? You take this and you graph it. You put it in the graphing calculator. You put this in a graphing calculator. You put this in a graphing calculator, and you put that in a graphing calculator. Again, you have 3 hours. Most students I know try and leave after 2 hours. If you got that much extra time, take it. Spend the extra minute and a half. Not only pass this, do well in it, okay? Number 20, which I categorize as a algebra problem. When g of x is divided by x plus 4, the remainder is 0. This screams remainder theorem, okay? Given that g of x equals x to the 4th plus 3x cubed minus 6x squared minus 6x plus 8, which conclusion about g of x is true? Okay, now look what they did. They gave you a question where you had to find the false one. There were 3 true, and you had to find the 1 false. This one, there are 3 that are going to be false. You need to find the one that is true, okay? So again, read, know what you're looking for, because the test likes to, give you a mental, breakdown, I guess. Let's just do this problem. Number 20, which is true. Okay, I know by the remainder theorem, okay, if x plus 4 is a factor, the remainder is 0, right? That means I could solve for this. If this is a booty cheek, I could T-bone it. X would equal -4. By the remainder theorem, I could take this, throw it in here, and it gives me the remainder. This is going to be my remainder. The remainder should be 0, shouldn't it? If I put -4 into g, it should equal 0. Oh, bam. Look at that. Look at that. Perfect. Perfect. And all you got to do is know the remainder theorem. This is a complete question that asks you what you know about the remainder theorem. That's it. I could divide those out. That's fine. I should get the remainder 0, but that still is going to help you know that g of -4 equals 0. You would have to do this with a calculator. If you did not know the remainder theorem, throw 4 in here and all your x's. See if it equals 0. It probably doesn't. It doesn't because it's not an answer. You would throw -4 in for all these x's, and it would equal 0. Boom. So you could do that algebraically without knowing the remainder theorem. 21, another algebra problem. Joelle has a credit card that has a 19.2% annual interest rate compounded monthly. Yikes. She owes a total balance of B dollars. B is dollars. After M months. Okay, this is like your X. This is like your Y. And when I say like, it is. This is your X variable. It's your Y variable. Right. Assuming she makes no payments on her account, The table below illustrates the balance she owes after M months. Here you go. So we look down here. That's a lot of scratch this girl owes. All right. So it says, over which interval of time is her average rate of change for the balance on her credit card account the greatest? Rate of change is what should jump right out at you. That means slope. Okay, so which slope is the greatest? And they give you on which interval. These are the intervals. When the month is 10 to when the month is 60. When the month is 36 to 72. We're just going to have to do all these slopes. Okay, we have 4 slopes that need to get done. Okay, so first, let's look at slope 1 from 10 to 60. It's a change in y over a change in x. Okay, so my change in my y value over the change in my x value at those points. So here's the one coordinate, my x and my y. Here's the other coordinate, my x and my y, and I'm just going to do this. Okay, I'm going to take 2591.90 minus 1172 all over 60 minus 10. All right, and I'm going to go ahead and put this right in a calculator. There it is. Let's quit this bad boy. And I'm going to use alpha y equals enter because I can. 2591.90 minus 1172. Put that all over 60 minus 10. All right. And that gives me 28. If this is money, let's call that 2840. Okay? So that's 2840. That's for the one in green here, for number 1. Let's look at number 2, from 19 to 69. So now I'm going to go from 19 to 69. I'm going to do the same thing. 2990 minus 1352 all over 69 minus 19. All right, well, let's put that in a calculator. See what we got. Alpha y equals enter. 2990, okay, minus 1352. Put that over 69 minus 19. Oh, it didn't come out. Why did that? Well, because there's a decimal in there. So if I take 819 divided by divided by 25. 3276. 3276. So right now it's not 1. 2 is bigger right now. Let's check out number 3 from 36 to 72. From 36 to 72. And I've got 3135.80 minus 1170.80 all over 72 minus 36. Let's put that in the calculator. Mister, it's a lot. Quit your complaining. Just do it. It's really, really easy. The calculator is doing all of this work for you. Minus 1170.8 all over 72 minus 36. Ooh, 5458. Wow. 5458. Number 3 looks like it's bigger slope. Let's try last one. Last one. People. From 60 to 73. From 60 to 73. All right, look at that. So we got 3186 minus 2591.90 all over 73 minus 60. All right, after this, we're going to have our answer. So alpha y equals enter 3186, minus 2591.9 all over 73 minus 60. 45.7. So this is 45.7. This is the biggest number, therefore the biggest average rate of change, and that was choice 3. No other way to do this. Ooh, look at that. The volume just went up to 4. No other way to do this. All right, you're just going to put it in your calculator. You're really just using y2 minus y1 over x2 minus x1. This is change in y over change in x. You've been doing this since 8th grade. You just do it 4 times. Easy. And by easy, right, if Mr. Visca could read, look what I did here. Man, this is why it's worth checking your work. See what I did here? This is 17, 70, 80, right? That number should be a 7 right there. 1770. Wow, that could change our answer. So let's go back here and say 17. Let's make that a 7. Yeah, 7 would be nice. 17, 70, 80, and hit enter. That does change our answer. Wow. Woo. Man, I'm on a roll. And when I say a roll, I made 2 mistakes, but I caught them both. Normally, 37, 92, let's call that. This is not the answer. It's this one. Woohoo! Take that extra time. Do that. Man, I just so happen to be looking at that. Look at me go. Check your work. It's really important. Okay, number 22. Which graph represents a cosine function with no horizontal shift, an amplitude of 2, and a period of 2 pi over 3? Straight out trig problem. Let's go ahead and do this. Graph represents a cosine function. Okay, a cosine function is a cup. It should either start up high, like that, or it should start down low. It does not start in the middle. This starts in the middle, that's sine. This starts in the middle, that's sine. So I know it's either 1 or 3. Okay? So, let's take a look at this. Has an amplitude of 2. That means it goes up to 2 and down to 2. Okay, this one does. It goes up to 2 and down to -2. Okay, this one does. So the one thing that is going to help me determine whether it's 1 or 3 is the period. The period, all right, that's the second time that's happened. Now we go up to 5. The period is the length of one cycle. One cosine curve, okay, let's say go up, should end at approximately 2 pi over 3. Okay, 2/3 pi. You see this here? It ends here, but that's 1 cycle, 2 cycle, 3 cosines in 2 pi over 3. We should not get 3 curves in 2 pi over 3. We should get 1 curve, which means, okay, I hope you know that 2/3 pi is less than 1 pi, right? Here's 1 pi. Here's 1 curve. It stops before then. And that's approximately 2/3 pi. Okay? Your answer is choice 3. 23, another algebra problem. According to a pricing website, Android. Oh, look how clever. They combined iPhone and Android and called it Android. Okay, anyways, an Android phone loses 58% of their cash value over 1.5 years. Which expression can be used to estimate the value of a $300 Android phone in a year and a half? So in a year and a half, I'm going to lose 58% of my 300, okay? The easiest way I'm going to do this is I'm going to take 300, okay? If 100% represents the value of the phone and I lose 58% of that, that means it's only going to be worth 42%. So after a year and a half, what is 42% of 300? Well, I multiply it times 0.42. All right? So I'm going to take my 300 and I'm going to multiply it times 0.42. That should give me $126. So after 1.5 years, this is what my phone is worth. All I'm going to do is plug in each one of these, I guess, expressions in the calculator and see which one is actually equal to 126. I mean, that's the easiest way to do this. All of these choices, 1, 2, 3, and 4, none of them have a variable. That E is a number. It's an irrational number, and it's in the calculator. Okay? So let's look at choice 1. I'm going to take 300 multiply it times e raised to the negative 0.87. E is above the division sign in blue. It's right here, okay? Or it's above ln. This is e to the x. What's the difference? If I just do this e, it just gives me the e. If I do this one above ln, not only will it put the e, but you see how the x is here? It'll automatically put an exponent box there for us. So you might say, Visca, can I just do this and then put the exponent? You can. It's the same thing. All right? Our exponent is negative 0.87. And if I hit enter, 125.68. Okay? Which one can be used to estimate? That's going to be my answer. Let's just try the rest of these. That's going to be the answer. That's the closest. I can't see anything else being closer to 126. If I had to round to the nearest dollar, it's choice 1. Let's put in choice 2. All these other ones are less. Okay, so if I try choice 2, and it's further off, these are going to be even further away because the exponent is just continually dropping. So let's do the same thing here, and let's put a 0.63 in as the exponent. 63, enter. Yeah, 159. And if the exponent gets even, I guess, a bigger or a smaller negative number, this value is going to get higher and higher. So it is choice 1. That's our answer. That's the closest to 126. Choice number 1. Our final problem, number 24. Again, I put this under miscellaneous, but I guess it could be under algebra too, as it deals with slope. Let's read the problem. A cardboard box manufacturing company is building boxes with length represented by x plus 1, width by 5 minus x, and height by x minus 1. The volume of the box is modeled by the function below. Let's take a look at what we got here. There's our graph. Nice, beautiful. Over which interval? Again, these are intervals. That means when x is 1 to when x is 2. These are not coordinates, okay? This is from when x is 1 to when x is 5. When x is 0, to when x is 3.5. When x is 1 to when x is 3.5. These are intervals. Which interval is the volume of the box changing the fastest average rate? Okay, rate is, again, slope. Okay, if it's changing faster, that means it's the biggest slope. Again, know what you're looking for, and this becomes really easy. Change in y over change in x. And let me reiterate one more thing. When you're doing these things, it's real easy to make mistakes. I've made 2 so far this video. I caught them both, thank goodness. There's nothing worse than putting up a video and you make a mistake and you leave it up without correcting it, okay? You're going to go through this fast. You're going to go through this maybe slow. You're going to be tired. Get sleep, all right? But more so than anything, just glance over your work and make sure you didn't make a single mistake, because that's what costs you the most points, all right? So let's figure out the slope from when x is 1 to when x is 2. Okay, here's when x is 1. That's at 1, 0. Here's when x is 2. Oh, boy. Let's call that in the middle. Okay, these go up by 2. So in the middle here, that's 9. So 2, 9. So I'm going to change in y over change in x. I've got 9 minus 0 over 2 minus 1. That's 9 over 1. That's a slope of 9. All right. Let's look at choice 2 here. Okay. 1, which is still here, to 3.5, which is about here. And that goes all the way up here, which is to 17 in the middle here. Okay, so that's 3.5 to 17. So let's do this. We have, make sure we include this here. Okay, 17 minus 0 all over 3.5 minus 1. Okay, so it's going to be 17 over 2.5. And I know for a fact that's going to be less than 9. I want to say 6.8. Well, let's do this. 17 divided by 2.5. 6.8. So far it's not this one. 9 is definitely bigger. Let's take a look at 1 to 5. This is 1 again. 5, oh, that's at 5 comma 0. Okay, changing y over x, it's 0 minus 0 over 5 minus 1. 0 over 4, which is 0. Well, 9 is definitely bigger than 0. And now, last but not least, we are going to go from 0 to 3.5. So we have our 3.5 right here. 0. Okay. When x is 0, that goes 0, negative 5. Let's see that. So we're going to say 17 minus negative 5 all over 3.5 minus 0. So that's going to be, when I subtract the negative, it's like adding 22 over 3.5. Well, that's less than 9 as well. I think that's 6 something, maybe 6.2. 22 divided by 3.5. Let's call it 6.3. Let's round that up, okay? 6.3. That is not bigger than 9. 9 is your winner, lobster dinner. Choice 1. That's where your box is changing the fastest. Okay, that is the biggest slope. Again, thanks for tuning in, my friends. We're going to come up with a 4th video, which will be problems 25 through 31, somewhere around there. And we'll go over problems there. We will take our time. If we have mistakes, let's catch them, people. Don't give up points because you're forgetting to, like, subtract a negative makes positive. Or if you just look at a number and you write it down wrong, because that happened to me. I looked at a 7 and I made it a 1. Good thing we caught it. We're still perfect on this test. All right? We'll see you.